Everyone, it's that time again. Today is day 28 of Coding Every Day. Yesterday, I looked at the first graph problem in this node in this graph here, which is number of islands. Today, I'll be continuing, and we will look at max area of island, which I have not read before. So today is February 12th. 2025 at 2:32 p.m. Today is a Wednesday, and let's get started. Okay, so for those of you who did not watch yesterday's episode, it looks kind of similar in that zeros are water and 1 is land. So we want to find the area, which is the number of cells within the island. So I think we're going to do the exact same thing, except when we depth first search, we're going to count the number, like the area. Okay, so this is a good practice. I'll write it from scratch again. So essentially what we're going to do is, if this is our grid, we're going to scan every position. If it's a 0, just move on. If it's a 1, we will DFS that island like this. Let's say our island looks like this. And basically every time I, in this case, pop from our stack, I will add 1 to the area. And then we keep going. Let's say there's another island like this, right? Okay, so those zeros shouldn't be there. So let's say that's the island, so our index is here. So then we'll go here to 0. When we go here, it's a 1, but it's already been explored, so we're just gonna ignore it. Okay, so I'm gonna say for row in range length grid. So these are numbers. So for column in range length grid of 0. So row and column are numbers. So I'm going to say search row column. So we will have a function called search, which takes in a row and a column. Numbers, so these are both numbers, row number and column number. And we're basically going to just DFS this point if it's not a 0. So if we say if grid of row column equals 0, then we should return. Or if row column is in visited. So we're going to have a set called visited, and every time we visit a 1, we're going to add it to visited. So visited will be a set of tuples, which is a set of coordinates where every coordinate is a tuple. So in this case, we'll get out. If it's a 1, so if we get to this point in our code, it means it's an unexplored 1. Unexplored 1, people. All right, so then what we're going to do is DFS it. So we are going to create a stack, which is a stack, and then we are going to pop from that stack. So basically just a DFS current equals stack.pop. So I'll just say RC. So now this is our current row and column. And this initializes the stack to contain whatever we did here. Okay, so now to DFS, we want to explore in all 4 directions. That didn't really work. You get the idea. All 4 directions. So like this one, we'll explore up, left, right, down. So the way I like to do that is I iterate through basically all 4 of those directions. So I'll say for delta row, and I did the same thing last time, for delta row, delta column in, and then we'll have a list of the 4 directions as tuples. So delta R and delta C. So for instance, to the left would be the row stays the same and the column goes back by 1. So this signifies left. So then this will get unpacked, and delta R will be 0 and delta C will be -1. And then it's going to do it for each direction. So that's left. Up is up 1 row and the same column. To the right is the same row and +1 column. And down is +1 row and the same column. Okay, so we can get our new positions that we're checking equal to whatever our current row is. So this will be like the row that we're checking. So if we're here, this is RC, position RC, and I want to check here, that will be position new R, new C. So I'm going to define those variables. So new R can be defined as R plus delta R. So for instance, if we're at position 1, 2, row 1, column 2, and we want to check to the left of it, our new position would be, let me just do this. So if we're at position 1, 2, row would be 1 plus 0, so the row would be the same, and column would be 2 plus -1, which would be 1. So we'll check 1, 1 instead of 1, 2. All right, so this is our new position. And now what we want to do is, if it's not invisited, so if it's bounded, so for instance, if we're here and we check up, we don't want to, that's going to give us an error. So first we have to check if it's bounded, which is a function I will define shortly, like this. So if it's bounded and it's not invisited, so new row, new column, not invisited, then we want to add it to our stack to be explored. So for instance, if we're at this one right here and we explored down, this is valid. So we want to now explore this node in the island. So we will append the tuple, new row, new column, like this. And then that's good. And then after we explore all 4 adjacent points in all 4 cardinal directions, we will add the original points to visited. So we'll say visited.add row, the tuple row column. So that way we don't explore it again, because if we don't add that, we could just infinitely go back and forth between those 2. So essentially once we check if we, so like let's say we're at this position, we check if we add this, 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 and then we mark it off as visited. Okay, so now I have to write the bounded function, which I will do here. So it's going to take in a position. So bounded is going to take 2 parameters. Maybe I should just make it take 1 tuple. I'm just going to do it this way. I wonder if it would get unpacked, or if it would say, I'm kind of curious about that, if adding the extra parentheses would matter. So for now, I'm gonna test that out quickly. So this function is not going to do anything. And then I'm going to say if I call bounded, so I'm just going to exit on my program, but I want to see if this gives me an error. So I'm going to pass 1, 2 in a tuple. Yeah. Wow. Okay. So this, because it's in these extra parentheses, counts as only 1 parameter. So it's assigning this tuple to the row variable. And it's not having column assigned to anything. So similarly, if I just pass 1 number, it'll give me the exact same error, missing 1 positional requirement column. Right. But if now I do the same thing without the parentheses, this should work and print 1, 2. Yes. And just that's because I'm returning nothing. But as you can see, 1 and 2 got printed. So in terms of design, honestly, so really the only thing that matters is that it has to be consistent. But honestly, I think in terms of design, we should think of it not as two elements, but we should think about it as we're passing one coordinate, which is a tuple. So I think we should do this. And when I call it, we should do this. So now we're passing in the coordinate, and then this receives a coordinate. And same with the search function. We'll take a coordinate, and we'll pass in a coordinate. Okay, I don't know if this is bad design. And that's all I'm going to say about that. But I think it makes sense. Okay, so we're going to return. So now let's go back to the original problem. So if it's, so we're checking, this is going to return a Boolean. So the condition is we want to check if this is bounded. So if the row is less than the length of grid and it's greater than or equal to 0, that's valid. And the column is the same thing, but for the the number of columns, which we can define as length grid of 0. Okay, so this will work. So if it's bounded and it's non-visited, then we append it. Okay. So now and then when we search, we do that down here. Okay. So for now, what I want to do is I just want to print to make sure everything's working before I start solving the area problem. So here I will print R equals and C equals, and then I will say explored like this. And it's going to say that I'm not returning anything probably. Okay, so I know why this is happening. I'm just thinking of the best way to fix it. So maybe I could say row column. So just unpack it here, because I guess you can't unpack it like in the function call. But I don't know if this seems like kind of, I'm just going to do it where you pass in the row and the column. And just do that. And I think that's fine. So here we will just do that and this. Okay, I think I might have made an error somewhere. Visted is not defined. Where do I have visted? Line 38. Line 45, 38, 62. Is it right here? Okay. Visited. Okay. So 0, 0. So 0, 0 is water, right? Yeah, so it shouldn't. So this should get out. So I don't know why. Okay, so the issue I'm having is that it's saying 0, 0 is explored. Is it because of here? Yeah, it's because here I'm adding it. But the first one should be 0, 1. Or no. row 1, column 0. That's correct. But also we don't want to add it to the stack if it's water as well. New row. I don't think that's going to fix it though. 0, 0. So let's just debug it once at a time. So searching. So I'm just going to see if this is doing what I want. Probably should have commented out the other one. Okay, so 0, 0 is exploring everything, which is not what we want. So this part is not working. Let's print grid of row column. I'm getting a phone call. 1 second. Okay, I'm back. All right, so I'm going to print what this is. It's 0. So why? That does not make sense. Is it not a string maybe? Oh, is it a list of integers? Oh, okay. So I was checking for the string. Perfect. Okay, so the problem was I was checking for a string, but it's a list of integers. Okay. That makes sense. Okay, so when we search 0, 1, and then it goes 0, 1, 1, so row 1, row 0, column 1 is right here. Row 1, column 1. So I don't really want to say that. So I think it's right here is when it, but it should be new R. Because this is when we meet all the conditions. And then also, this should also be an integer. Okay, so 0, 0, 1 never gets printed. So 0, 2, 1, 2, row 2, column 2, row 2, column 1, row 3, column 1. So it's gonna, the area of that island is equal to all of these plus 1. So we could say up here. So I'm thinking what we would say is area equals 1. And then here, area, excuse me, area plus equals 1. And then when we're out of here, we'll say print area equals like that. So this one, area is 6, 1, 2, 3, 4, 5, 6. So 0, 4, 0, 4, 1, 2, 3, 4. And area is 1, and then searches the rest. Okay, so it seems to be working. So I'm going to comment out these print statements. So here we'll say we'll just say max area equals the max of max area and area. And we will say max area equals -1. What if there are no what if it's all zeros? Is that possible? What do I return? Probably 0. Okay, and then let's return max area. Yeah, so this is a local variable, right? So if I say this, it'll work. I could also pass max area. Right? No, I think. So the problem is, yeah, I'm trying to assign a global variable. So I think this works. It's fine. It's okay. Okay, so let's see what's wrong with this one though. Use test case. So my output is 5 and the expected output is 4. So let's draw it out. And we will deduce what is happening. So 1 1 0 0 0 1 1 0 0 0 0 0 0 0 whoops 1 1 and 0 0 0 1 1. Okay, let me add my print statements back and see what is going wrong. Okay, so 0 0 is explored. 0 1 oh I think I need to say visited. I have to add this one to visited as well. Like that. Could that be with the problem? No. Okay, so both of them are returning area 5 when they're only area 1. Oh, it's because I'm adding them. Okay. So I search this, and then it's an unexplored 1. So then it's 0 0 is explored. And then we check to the left, which is out of bounds. We check up is out of bounds. We check to the right. It's not in visited. So we explore it, or we add it here. This is the wrong place to... So maybe instead here I should say, I should check these conditions. And then let me try doing that. So if it's not bounded, RC, continue. If RC invisited, and if grid RC equals 0, so I'm thinking, I don't know, so that didn't work. Okay. Let me go back to what I had. I thought maybe it was this would, like the way that area is being added didn't make sense. Okay, so 0, 0. So 1, 1, 0, 0, 0. 1, 1, 0, 0, 0. Okay, so my diagram here is correct. So we first explore this one, and then we add all of the possible neighbors. Let me print here. Popped. Just to help me debug it a little bit more. And then I don't want that anymore. Okay, so we popped for case 2. Okay, so we popped 1, 2, 3, 4 times only. No, 5 times. So we popped this twice, so it's being added twice somehow. 0, 1 is being added twice somehow. Okay, so from here, and then let's just say added this to stack, and then print here stack equals. So I'm just kind of putting in a lot of debug messages so I can trace what went wrong. So our stack is 0, 0, pop 0, 0, and we added to the right and beneath it, which is correct. That's what happened, what I would expect. So we added this and we added this. So now we pop 1, 0 from the stack, and then, so we popped 1, row 1, column 0, so this one right here. So we popped this from the stack, and we added 1, 1 to the stack. Okay, I think I see what's going on. Added 1, 1 to the stack, we popped R1, and then we added 0, 0 to the stack again. Yeah, so basically when we have squares like this, we add this one to the stack, and then we go and add it again. So obviously we could say if it's not in the stack, but I feel like I wonder if this is what was happening in my other solution, but it just didn't matter because of, yeah, maybe my DFS is bad. So this one, it actually matters. So I think in both problems I had the same error where this was happening. And you might just have to say, because I do check if it's not in visited, but we also need to check if it's in the stack. And I think that's why sometimes you like color them different colors, because if they're already in the stack. But checking if it's in the stack is linear, so there's got to be a better way. And this is a big issue, obviously, because if we have all ones. So just to make sure I understand the problem. So if, and I'm going to change this, but if we say, and could it be with visited? I'm always adding tuples to visited. And just to make sure I know it's okay, that didn't work either. Maybe it's like that. Okay, so this. Okay, so this is not the right way to do it because it is... And we can't add it to visited, right? Or else it won't add its neighbors. Yeah, I mean, I'm thinking... Huh, interesting. So I guess I have some misunderstanding in DFS. Which is good to know. I'm thinking what I could do is, it doesn't really matter. It doesn't have to be depth first search. It could be anything. So I don't know what would happen if I made stack a set and then just like popped from the set randomly. So that way we'd have constant lookup time. So this will give me an error, but I want to see if this line works, if you can pop from a set randomly. Okay, so this would be constant time. Okay, so I basically just made stack a set because we actually don't really need the order of how to pop things, and now this line is O of 1. Okay, yeah, so I think that's a good episode today. I am definitely gonna look at the solution and see I'm probably missing just a key part of the logic. Yeah, so the idea is how to make sure you don't add something. Nice catch. How to make sure you don't add something to the stack twice. And that's pretty much the only problem. So my solution for this problem, the temporary one that I thought of was like, okay, I'll just make stack a set because the order doesn't matter, and then we can just check if it's not in there in O of 1. But I feel like that's it doesn't seem right, especially if the order does matter and you want to do a DFS. I know there's other ways to do it. Anyway, so that concludes our episode today. Thank you very much for watching, and I'll see you guys tomorrow. Hey guys, I'm back. So I just wanted to say what I realized I was doing wrong. So the problem is I have visited outside of here, which is why it's adding things twice to the stack. So instead, what I should do is right here. So I should add to the stack, and then right after add it to visited. So that way, when we add it, so it's in the stack once, which is good. But then it also gets added to visited. So that means it can't get added to the stack again. And down here is not where we want it. We just, as soon as we add something to the stack, we want to put it visited so we don't add it again. And then, so I can put this back to a list. So like this. And I think that should work now. Yeah. Okay, so for DFS, when you add to the visited set is inside the for loop, not outside the for loop. Yeah, so just wanted to make a little update there. So thank you for watching.